All right. Started recording. Fine. So what we are going to do is every time. So we initially we'll take an empty dictionary. Okay, I'll go back to this code only. See what is memoization. This is like memoization of Fibonacci. All right. So as I told, they are going to put the values into a dictionary. I'll show you here. See this. So what is going to happen is basically mm, every time you calculate. So um we go to one side, it's either 4 or 3, that's okay. And I think in this case they are going for the bigger node. Okay, so 4 3 2 1. So every time you, so and you have a dictionary. Initially it doesn't have anything. All right, for the first time you calculate Fibonacci of 0, you put it into the dictionary. All right, so and what is Fibonacci of 0?
Zero.
Very good.
Zero.
Yeah, what is Fibonacci of 1?
It's one.
Good. What is Fibonacci of 2? For 2 you are going to
It's one.
calculate. Yeah, you're going to calculate, right? Fibonacci of 2 is going to be Fibonacci of 1 plus Fibonacci of 2. So when you add it, it's going to
Zero.
be 1, right? So you have done some
Fibonacci of
calculations. You are
two.
adding the values. All right. So you are now, after adding, you are putting into the dictionary. Okay. Next time when you see 2, you can directly access it from the dictionary. Now see on the right hand side, Fibonacci of 1 you have, but you're already having the key in the dictionary, right? So you can access
Yes,
it
sir.
directly. So you don't need to calculate it. So that's the point over here. See Fibonacci of 3. Like see the next time you're going to do Fibonacci of 3 is what? It's going to be 2 plus 1, which is like 2. Okay, next time you come to this place, so it will directly access from here, and you're avoiding all the the nodes on the right hand side. All the whole tree, right hand side tree, is being avoided. So this is a faster technique to find the Fibonacci. All right, do you guys understand the little bit of concept here, guys?
Yes, yes.
Okay. um, that is called as memoization.
Sir, I
Memo.
have a doubt, sir.
Yeah, talk.
Sir, I'm unable to understand this. Like, you're starting from the bottommost and you're going to the top, but
Mhm.
in the question it will be given like you have to find Fibonacci of 5. Then you have to start it from 5 and then you have to go in the reverse order. So,
Okay,
how it
wait. I'll
happens?
come. I'll come. Let's go through the code. Will that be helpful?
Yes, sir.
All right. So we are given a number. So Fibonacci of, let's say, 5. All right. Hmm? So if n is less than or equal to 1, you put memoization. Like this is a dictionary, right? So you're gonna put. Shall I take this to a you know to a collab, just like how we used to do? I'll be able to do it now. It's gonna take some time. Fast. Create a new notebook. Didn't I create a new notebook? Yeah, Ravina. So shall we start? Like, so Fibonacci of 5. That's what we are trying to find out, right? Hello?
Yes, sir, I'm listening.
Yeah. So if n not in memo, so see for the first time it is 5, right? First iteration. So is it there in memo? No, right? If it is not there in the memo, and memo of n is going to be Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is going to be called, we are going to call the function for 4 plus Fibonacci of 3, right? Okay, it's not double slash, it's hash. My languages. Fine. So if you want to find like that's the recursive part, right? So you need to find out the lowermost and then come back. How would I explain this? Is it, are you not able to understand this? Like, is anyone else also having the same doubt?
Sir, it's clear, sir. It's clear.
Uma?
I'm fine, Google. I understood. I got it. It's fine.
Okay. So, what should I say? Okay, let's go to code. Can someone help me here, please?
Sir,
Uma.
it's clear. We can move ahead.
Yeah, but look, we are looking at the code here. So every time,
Tell me what do you want?
yeah, Uma. Are you here?
Yeah. Tell me.
Okay, so we are calculating here Fibonacci of 4 and Fibonacci of 3,
Yeah.
right? So for 3 also we need to it's going, we're going to calculate,
Yeah.
Fibonacci
2
of,
and 1, right?
for 3 we need to calculate Fibonacci of 2 plus Fibonacci of 1. Right? I'm going to put it in bracket instead of writing the whole thing. Okay. And what is the stop condition? If n is less than or equal to 1, memoization of n equal to n. Right?
1 and 0 is a base case.
Correct. So for 0, it is going to be, like in this case, it's going to be 1, right? For 1, it is 1.
Yeah.
When it comes to, this part.
Yeah.
So when it comes to 2, right? So it's going to be, and since 0 is less than 1, so it's going to be including 0 also, right? So this is how it is happening. Like, is this okay with everyone? I mean, I don't know.
No, sir. No, sir. Print it. Fourth line, print it, and sixth line also print it, sir.
Okay, wait. Fine. Fourth line you want me to print of memo, I believe, right? After sixth line. Why is it not happening? Okay, we need to pass some number. We need to call the function fib of 5. It's a recursive call. Ravina? Hello?
Yes, sir. I'm looking towards it.
Yeah. So Uma, are you also okay with this? Like, what is going to happen? This is fine. There's nothing in this. We don't
Yeah. This is understood. You can move on.
we'll move on. Give me a second. If we have any questions, we'll also try to do them. All right. This is matrix multiplication. That's not yet done. Okay. So there is something else called as dynamic programming, right? So what is dynamic programming going to do? So we'll go from bottom to top, right? So what happens is basically you have Fibonacci, you calculate Fibonacci of 0 and Fibonacci of 1. How would I explain this? Simple recursion memoization. Okay, let us run this. And
Sir, I have a doubt here. How it's storing in the memory the previous values, as it will go till the end, like the base case memo of Fibonacci of 1 only, and it is happening in every case, like of 3 and 2 and 1. Then how it is memorizing it? Like, I'm not able to understand it.
okay. So I'll tell you. Fine. I'll take this code. Okay, Ravina. So suppose that we are trying to find out the factorial of 5, right? In order to find the factorial of 5, you need to have two things, right? Factorial of 4 and 3. Yes or no, Ravina?
Yes, sir.
Okay, but we don't know 2 also, 3 also. So we go to 2 and find value of 1. This is how the split is happening, right? I think you're okay with this, right? How the split is
Yes,
happening?
sir.
2 1, right? 2, sorry, it's not 2 1, it's 1 0. 1 0 1 0. Okay. So, and see, look at this. We have a dictionary which is an empty dictionary. All right. Memorization dictionary, you can say like that. Okay. So, coming to the code, when you give n equal to 5, all right. So, it it's not if there is this condition satisfied, 5 is not less than 1, right? So we are not going to this part. We go to this if condition. If n not in memory, okay. If n not in memory, and it's not here in the memory, right? So we go to this part and we calculate Fibonacci of n minus 1, Fibonacci of n minus 2. So these are two different functions. Now this will run in two different parallelly, right? So you'll try to
Yes, sir. It means if, yes, sir, I got my doubt. It's clear. Like if it is already present in this memo, then it won't execute the seventh line. It will take the value from the previous line
very
only.
good. It will directly take from the dictionary. You're right.
That's right.
Okay. So probably that is clear now. And is that clear for everyone also? Mahi also? Pooja?
Yes, yes.
Good. All right.
Yes, sir.
See, there are three different techniques. Okay. First technique is, I mean, there are actually four different techniques. Using a for loop also we can find the Fibonacci, right? Right. So, but simpler ways, you can say like there are three different techniques. One is the recursive way, right? And another is the memoization. Just now we saw, right? What is memoization? Right? Having a memory table, something like that. So every time we don't find a value, we find a new value, we put it into the table. Next time when it is required, we take it from the table. And there is something called as dynamic programming. So this is a very important topic, all right? And I'll tell you about that. So we come here to the bottom. So they have find out the performance, all right? So see, we can see that recursion is taking somewhat like let's say 7 seconds, all right, and storage memoization took just 5 seconds, and it's like e power minus 0.5. It's going to be very small, all right. And we can see which is the fastest. Dynamic programming is the fastest, all right. And we look at what is dynamic programming, and what I tell that here. Do they have a way to do that? Interval scheduling. These are all sub problems. Weighted interval scheduling. What is this? We don't have anything. Ma, do you have anything regarding dynamic programming in this?
So many things comes under dynamic programming. You can't conclude as a one thing, right? It's basically calculating the sub problems. Right?
Yeah.
So I'm also not very sure of dynamic programming.
Okay,
I think it depends on the problem.
yeah, I just want to give a brief explanation about what is dynamic programming here, nothing else. So can you help me
Okay.
here? Same thing is happening, right? But in this
Yeah,
case,
the problem, the difference, I also don't know. I asked the live session, they told in memoization, you're calling the recursively, right?
yeah.
It's like you're calling for fig 5.
Mm-hmm.
It looks like you're already calculating 5, right? But
Correct.
in dynamic programming, you start from the first, like you divide it into sub problems. You start with the last one, then go up. It's like that.
That's right.
So it depends on the program. I couldn't explain theoretically.
Mm-hmm.
Like there are so many, we have no PPA and things like that. Only if you watch those things, you can understand what is dynamic programming.
So let's see what is happening here. All right. So here also they are trying to find out Fibonacci using dynamic programming. Let's say 5. All right. So t equal to 0 times n plus 1. So n plus 1 is basically n is basically 6. I mean 5, right? So Can you tell me how will this line look like after this? Yeah, Vikram, please talk.
Yes. So we will have 6 zeros in the list called
Very good.
T.
Yeah, that's right. 0, 0, 0, 0, and 0. This is what happens here. Uma, are you okay with this? Do you know about
Yeah,
this?
yeah.
Yeah, nice. So, and T of 1. So, T of 1 is basically this part, right? And they're going to make it as 1. Okay. So, basically, they're going to calculate and put it in this list, I think, right? So, for I in range of starting from 2, like these two are the base cases. First, we are going to find out the base cases, which is for 0, 0. For 1, it is 1, right? For range of 2, 2 to 6, that means like, um, it will go till it will stop at 5 in this case, and t of I equal to t of I minus 1 plus t of I minus 2. Fine. So we start from 2. So 2 equal to 0 plus 1, which is 1. For 3, it is like we are going the reverse. Am I right?
Yeah, yeah, correct. That's it. You're
Yeah.
going from bottom to up, right?
Yeah. For third iteration, it will t of I mean t of 3 will become 2, and t of 4 will become the previous sum of the previous two, which is 5, and for 5 it will become 5. So that is what is going to happen here. So this is how the dynamic programming is going to happen. So it's just the opposite, right? In memorization, we go with the
Yes.
small we split and add, divide and conquer, let's say like that, right?
Not exactly dividend conquer. We are
Yeah.
coming from top to bottom.
Huh.
But here we start from the base case and then build. That is what the diagram shows. No,
Yeah,
fifth
yeah,
of one, it goes up.
correct,
But in memorization, we do a recursive call
correct. So we go
from.
hmm. So we have these two base cases. From that, we go to 2, right? From with 1 and 2, we are going to 3, and 2 and 3, we are going to 4, right?
Yeah.
Okay. So does this give a brief idea of what is dynamic programming to others? Anyone is having any doubt here? Anwar, Mahi, Ravina, Subramanyam? Okay, fine.
Okay, sir.
Yeah, that's good. And so, correct. So we come to the implementation of dynamic programming. All right. So we have a rectangular grid of one-way roads. All right. So all these are like you can either go straight or go left or go right. There is no opposite way. All right. So we have the grid path algorithm or something like that you can call, right? Can go up and right. So only two ways. All right. Either you can go up or you can go right. And how many paths from 0 to m comma n? See, so from starting from 0, we have m comma n is like 5 comma 10. So the question is like how many different ways you can go. That is what we are trying to find out. um in this case, we are able to see three paths, right? I mean, the blue color path and the yellow path and the red path. Can someone try to guess how many paths it can have, guys?
It's kind of 15 choose 5 and 15 choose 10. Or I think so.
So if we say that this point is going to be 0 comma 0, and what is this point going to be? 1 2 3 4 5, right? So on the x-axis it's 5, and 0 1 2 3 4. So that point is 5 comma 4. All right. So shall we talk about the different, I mean, or else we can have a smaller one. Very simple. Okay, 0 comma 0, and this is going to be 2 comma 2. Can someone tell me how many different paths we have? So given that you can go either right or up, here 2 3 4. So basically we can write it out now. So right up up. Okay, that's the first path. What about the second path? Can someone just give me an idea now? Tell something.
5.
Huh?
5.
No, it's not 5. I'm saying that, see here, right up up.
No, sir, 5 parts. It can be 5 parts.
Total 5 paths. How did you tell that?
One is the last line which you have drawn,
Correct.
and similarly, one can be from up, up, right, right, and one can be
Mhm.
up, right, right, up, and
Up,
one can
right, right,
be
up. Yeah.
right, up, right.
Mm-hmm.
And what was the last one which I calculated? It was fifth one. Oh God.
Upright, upright. See? Upright,
Yes, sir.
upright. You can go like this also. So this
So
is a smaller
fine.
one, just two cross two. But ideally, we'll have more places, right? When it goes to like 5 cross 4, 5 comma 4. How would we calculate it? So we have the formula. I don't remember the formula. Umar, you just now told, right? What is the formula about?
Yeah, it is actually total that thing, no? Five rights and 10 apps, right?
Huh, that's right.
So it is like 15 choose 5, that will be its set of paths, or 15 choose 10.
Okay, let's say like
Suppose
5 5 4.
in
Like
left, yeah.
let's say 5 4. Okay, I want to know how to do this. Tell me.
Okay, 9 C 5, 9
Right.
choose 5. You can
Nine
do that,
choose five.
or 9 choose 4.
Nine choose five. Tell me.
Or the other way, like 9 choose 4.
That's all.
I think so. Whether it add or I'm not, I saw the lectures. I'll confirm maybe.
Okay, you can tell about that, or should I look at the lecture?
Yeah,
Right.
yeah, it will be.
There is nothing in this here.
No, in the grid project,
Yeah, yeah.
go for grid. Yeah, grid paths.
Grid paths. Nice. They have
Yeah,
come to this part.
Previous example, there are 6 parts. 4 choose 2.
yeah,
Mhm. So probably we missed one. Right. So that's what I was trying to calculate it. So
yeah.
it's if it is 4 choose 2, how would you do this?
It should be 6, right?
Rows plus columns.
Yeah.
And then we are going to fix. Now there are 2 rights we can take maximum, right?
Correct.
In this. And 2 ups we can take maximum. So we need to fix one of that. So if
Okay.
you fix 2 rights, which means 4 choose 2.
Fine.
So you have taken a square example. If we have taken something else like
Hmm.
uh,
In this
3
case,
by
we wrote
7,
6, right? Which case did we miss here?
which case we must.
Right, right, up, up,
Uh, must be up, right, right. Have you written that? Up,
up,
right, right. Yeah.
up, right, right, up. Yes, is there.
Right up, right up.
Right up, right up. Yeah, it's not there. You're
Yeah.
right. Right up, right up. So we got 6 cases, which is nothing but 4 choose 2, right?
Yeah, then it is correct.
Yeah. All right. So it's just the formula is just 4 choose 2 or 5 choose 2, whatever it is, right?
Yeah, the total and how many rights you have that you can choose, right? Keeping one as a constant, you can choose variables. That is how the
Okay.
formula
So
works.
so 5 comma 10, it's like 15 choose 5 or 15 choose 10, but both are equal.
Yeah, yeah. That is why I told R.
Hmm. Fine. So that's if that's the case, then we'll move forward. All right. So and the question is like, let's go. How many different ways that we came up with the formula? Um, okay. The question is like, what if an insertion is blocked? What if you are told that okay, if this here there is a block, or okay, we'll come here only. Yeah, it's here, right? Ma, whatever you told. 15 choose 5.
Yeah, yeah, that's right.
What if an intersection is blocked? So if there is a block in this place, so how many different paths will be blocked? That's the question. Okay, for instance, 2 comma 4. So two earlier examples. So see this path in this. So starting from here, and if you are going till 5 comma 10, this path you won't be able to take. So
So sir has told in the lecture, up to that block partner, we can't find how many paths are not included. So what he did is, up to the block, you can find how many number of paths. Then from that path, you can calculate, you can subtract from the total one. It's kind of like that.
that's correct. So what you are telling is, so we can't directly calculate it. So we are going to calculate how many different paths are there from 0 comma 2 to this 2 comma
That
4, right?
particular, yeah,
Huh. So how many different paths are available? So from
Yeah,
all
to
those paths
subtract
will become invalid, right?
yeah, yeah, yeah.
And we will minus it.
To go down, you can see
Yeah.
that.
We count these separately. Huh. See, every path via once again. Why is this? Yeah. Every path via 2 comma 4 combines a path from 0 to 2. I mean 0 to 2 comma 4 and 2 comma 4 to 5 comma 0. All right. Count these separately. Yeah. So this is like 6 choose 2, right? And that is going. What is this 3? Oh, what is this 9 choose 3? Okay, come starting from this point. Fine.
Yeah,
2 comma 4 to 5 comma 10. How will we
yeah,
find it?
yeah.
It's the same, right? Okay. Yeah. The question is, how do we find out the total number of ways possible starting from here? It is 2 comma. What is this? 0, 1, 2, 3, 4. Yeah, 2 comma 4. The question is like 2 comma 4 to 5 comma 10. How do you find out? If it is like 0 comma 0 to 5 comma 5, it's easy, right? We just told how much it was. It's just 15c 5. Am I right? So how do you find it here? Mahi, Ravina, you want to say something? Any idea? Any guess? It's easy.
So what's the question?
The question is like earlier we saw starting from 0 to reach a particular point. We just did, sum of the point plus choose 5 or something, right? We remember 0 to 0, 0 comma 0 to 5 comma 10. How many different possible ways are there?
Is 15 choose 5 or 15 choose 10?
Correct. That's right. So the question is, if it is given 2 comma 4 to 5 comma 10, if it is in between, how do you tell it?
So we can do it like from 0 to 2 comma 4 we can calculate, and then we can calculate from 0 to 5 comma 10, then we can subtract these two.
The question is 2 comma 4 to 5 comma 10, not the whole thing. Just 2 comma 4 to 5 comma 10. Array, it's easy, yaar. Uma, you want to tell?
Yeah, you subtract it first
Ah,
row.
5 minus
5
2.
minus 2, 10 minus 4.
Uma, 10 minus 4.
4.
Right. So, oh, no, what is
So
it?
that's what we will get if we subtract it from 0 also,
Right. Uh,
because it's just the distance and relative distance it is now.
mhm. What did you tell? You told starting from 0 to 10, right? Ravina, whatever you told was we'll calculate from 0 to relative distance. What are you talking? I mean, I'm not understanding. Can you tell me?
Well, path
I'll
cannot
leave it,
originate.
we can move on.
Yeah, Vikram, you want to say?
I'm saying path cannot originate from 2 comma 4, right?
Uh,
Path cannot start. So if 2 comma 4 is blocked, right? So
correct.
we are just looking for paths from 0 0 to 510. So we are worried about how many paths are passing through the block thing. Those are the paths we need to subtract. So I don't think so. You can find a path from 2 comma 4 to 5 comma 10
No,
because
I was just
No, no, no. It is a calculation we have to do, Vikram. Only then we can subtract the blocked one. Reality, we can't. But as per the calculation, only if we calculate from these, so that we can get the total path, avoiding that whole block. We cannot
yes.
travel through the whole, but we need that calculation, Vikram.
Yeah,
okay.
Vikram, you
So
got it
that
now.
for subtracting from the whole set, we are avoiding those parts. So we need it as the calculation. We are not going to go through 4 to 510. We can't go. But the calculation needs to be done and it is subtracted from the total.
Correct. So these are the total paths, right? So this is nothing but this 15 is nothing but from 0 to 2 comma 4, right? And this is from 2 comma 4 to 5 comma 10. So and since it's like various combinations are available, you're multiplying it, right? So from those path, you're subtracting. I mean, from the original total number of paths, you're subtracting it. Vikram, are you okay with this now?
Yes, yes.
Is it clear? Yeah. Or what about others, guys? For one block, Mahi, are you able to understand something? Please, you are very silent. Subramanyam, Anwar,
Yeah, yeah, I'm following.
Yes, yes.
great. Okay, fine. So we'll move to the next one. All right. So what if we have two insertion block? That is what is being discussed here. Discard paths via 2, 4 and 4, 4. Let's see how they are calculating it.
Now here, how many paths are between the two blocked holes?
Repeat.
How many paths are between the two blocked intersections?
Okay. So in this case, it's only one path, right? I mean, right,
Right.
nothing else. Okay. So that also we need to include here. Is that what you're saying?
Yes, I mean it's one for now.
Mm-hmm.
For example, if it would have been,
Different place
just
it
one step
might be.
above,
Yeah.
there would have been more.
So let's see what this code is doing. Okay, I think
Here,
yeah. Go ahead. Tell.
couple of slides are misprinted in the above slides. Those are not correct slides.
During the calculation only, they were not correct, right? Are you sure? I mean, I know that there are slides which is not correct, but these slides are okay, I think, right?
The earlier one, the I minus one.
No, but finally he said that is correct only, Vikram, because he thought it's a row and column. That is not correct. So he himself said that is correct.
So if we consider XY coordinate, then it is correct.
That I minus one, it is correct only. Finally he said it is correct. He misunderstood as a row and things like that.
For the inductive structures you're talking about, are you guys talking about
Actually,
inductive?
Vikram was pointing.
Sorry.
No, Vikram was pointing one slide where sir told initially corrected, but finally he said that is correct.
Okay.
Maybe he missed that. Yeah.
All right. So what is happening here? So here we are talking about dynamic programming, right? Again, filling up a total number of possible ways, like starting from here, and then how many paths you from starting from here to here, how many paths you have. Is that what is happening here?
Yeah, you're right.
Right. So we, in order to reach this point, we have 2 + 1. I mean, you need to take three paths.
Yeah.
Yeah, right. So 3 paths are available. So we are just going to
So
calculate.
he's filling row by row. We can also fill column by column. That's why
Yeah,
he's
that's
filling row by row.
for the first row. You just need to take all right. I mean, one single line is enough, right? So for the second row, how many steps it takes? Like, so is he talking about wherever we are going to start from here or something like that?
The starting is 0, comma 0, right?
Okay. Let's go further and see. Is this picture correct?
Yes, correct only.
Okay, if this picture is correct, then we'll try to understand this. Yeah. Okay. Where are we? So we start from here, right, Uma? So I think for the row we are putting all the zeroth row we are putting 1, right? The column also we can put.
Yeah.
No,
Right.
sir, I have a doubt what these numbers represent.
These numbers represent the number of paths. Okay, Uma, you want to tell?
Yeah, it's number of path at that point, particular point. If you take one point, I comma j, number of point up to that is 832, which you're
But like what the formula Uma told, they choose one.
no, no, that is
That
different.
doesn't fit here.
No, don't confuse with that. That is different. You
Uh,
can't do that because the block is there, no, Ravina.
No, no, before the block, if we take any point, like it's not valid till that point also.
I'm not getting what?
Gokul, there is a lot of
If we
echo from your
take that 3 point, if we take it, so
which 3 point?
uh, it's two right and one up.
Okay. Is this one? Is this what you're saying? Two right and one up. What do you mean? I'm not understanding. This one, huh? Or this one?
The three written here.
Yeah, right. This is what two right and one up. Ravina, is my screen visible, guys?
Yeah,
yes.
This is so how if from that formula it's not equal to 3.
no, no,
Um,
we cannot find always that choose point. We have to go by diagonal. We are filling by row.
So we
Actually,
have
the
the formula
formula,
IJ.
yeah, we have
okay.
formula there up, Gokul. Kind of like,
So I'll tell you what, like here it is nothing but, I mean, we take the left point, right point, we sum it up and put it here.
yeah, yeah,
That's
that's
all. That's
that
all we need to
diagonal.
talk. So two and one we have. So ideally, sir. So if you are having table, like, is it possible to insert tables in this? I don't think so. Fine.
Yes, sir,
So
we can move on, sir.
yeah, Ravina, what is happening here is like you add this one and sum it up and put it here. Simple. So how do you calculate for two and, I mean, if you add these two and one, you get the three. If you check, see, 13 plus 26. What is 13 plus 26?
I think Ravina's question is because why are we not using that choose 15
Ah,
choose
why
things?
we are not using it? Because
Yeah,
we
yeah.
have,
Ravina, that is because we have one block, it is little easy, but two blocks, three blocks, it is going to be very, very tough. That is why Sir is following this
No,
another.
no. I'm saying before that block only. Now that 3 point is that 0 and 0 is above 3. But if we need to find the path till that 3, where it is written 3, till that point also this formula is not working now.
what do you mean? So this point, right? Ravina, please tell, is this the point you're talking about?
Yes, sir.
Okay. So how many different ways are possible for three is that formula is not working? Is that what you're saying?
Yes, sir.
It is working, you check.
It's 3 comma 1, 4 choose 3, or 4 choose 1, right? What is 4 choose 1? Or 4 choose 3? 4 factorial by, is it, how do you get that? We can do the calculation here itself.
One and three, right?
3 choose 2, it is 3.
What did you say? 3 choose 2. How come 3?
Yeah, one row, two columns. So m plus n is
Okay,
3.
the point is, I mean, it's 2 comma 1, right? It's not 3 comma 1, it is 2 comma 1.
Yeah.
This point is 2 comma 1.
Yes, yes.
Yeah,
Correct.
if it is 2 comma 1, then it is 3 choose 2, right?
So how it is 2 comma 1?
Yeah, see, this is the starting point is 0, right?
1
0.
up and 2 right, right?
0 comma 1, 0
Okay.
comma
I
2.
started it from 1. Okay, sir, it's clear.
Yeah. So sorry, this is not right. Okay. So this picture dynamic programming, how what is happening is that, so you calculate from the base cases, right? Starting from 0. So you sum these two things and you get this up and add these two. Is this clear for everyone? I mean, when we have a block here, we come back to the point. So 6 plus 0 is 6 and 6 plus 20 is 26. 0 plus 26 is 26. Is this clear? Uma, are you okay with this?
Yeah, yeah. When you come to 0, it becomes 0. That
Correct. Yeah.
two, that's right. Yeah.
Ravina, Anwar, Mahi.
Yes, yes.
Yes, sir, it's clear.
Okay. So this is how you find out the number of possible ways when you have blocks inserted into the grid paths. All right. Is it clear? All right. So shall we also look at the code for this now that we have seen the implementation? Uma? Did you see the
Have to,
code?
yeah, I need only code. Yeah, yeah. I'm waiting for that
Yeah,
code,
all right.
please.
First we need to do that so we can. Okay. Do we have code for this?
I do not think so.
No.
Yes.
We have? Okay.
Mm, so for the same problem, I think they are doing the dynamic programming. Do we have code for this?
No, we don't have. Vikram, see?
Hey, Srivinay. Hey guys. Here's the official
Hi,
mentor here, Srivinay.
not the official mentor. Yeah, I'm the TA for pdsa, guys.
Yeah.
Hi, nice to meet you.
All right. Uh, so do we have the code for this?
No, I don't think they've pasted the code here,
Okay.
but I have coded it before. I don't think I can find it right now. I'll see.
Hmm. Probably we should only come up with that. So Uma, why don't we do something like this? So whatever we have here, shall we try to understand the code? What do you say?
Because these are different, right? It's a entirely different program. So
That's right.
we can't do for that. The other one is calculating paths, so we have to write a code.
Even if you want the code for this, then tomorrow we'll discuss that. What do you say? We don't have a code here, right?
Yeah, we don't have it.
Then we'll discuss that tomorrow. What do you say? Tomorrow anyhow
Yeah.
we have a session, conversation class. Shall we go ahead with the next one?
Dynamic programming doesn't, it's a different kinds of, we get very much different kinds of problems. Only the concept we should know. So
Mhm.
even code, even the GRP, PP are very different, but it comes under dynamic programming, right?
Yeah, that's right. Where are we? Yeah. Okay. For that code, we'll look into it tomorrow. But now, we'll move ahead. What do you say?
Yeah,
We'll, we'll go to longest common subword. Ravina, okay? Nickel? Hi, Nickel.
Hello.
Hi. Okay. So, what is this longest common subword? Okay, given two words. Yeah, Ravina. Ravina, say.
It's nothing, sir. Nothing, sir. Nothing.
Okay. So, we are given two words. In this case, we have secret, secret, right? And we have bisect. Oh my god. Give me. Okay. So, what is the common, sub LCW, right? Longest common subword. Is that what we say?
longest common word. Yeah.
Yeah. Right. So, in this case, it is uh,
Sorry, subword.
SEC, SEC, right? And there is something else is there, right? Longest common subsequence. Okay. So, which is SEC and T is also there. Am I right, Uma?
No, this is
No,
common
sir.
word.
It's
So
not.
it is, yeah, subsequence you can say that, but this is only word, right? So you
Yeah.
can't
In this case,
include.
yeah, we are talking about the word. So that means we should have continuous words, right?
Yeah.
Okay. So how to calculate that? What is how to calculate that? That's what this problem is. And how do we do that here? Once again, I just close the door. There's the background noise. Okay. Okay. How do we calculate? How is this calculated here? So we just write these words, right? Secret as a, I mean, we just take okay, what is the length of secret? It is 6, right? Length of the word secret. It is 6, and bisect also is 6. So we create a 7 cross 7 matrix. So it's basically n plus 1 cross n plus 1 matrix, right? And for the initial table, like just like how we used to do earlier, here we put 0 and all these things 0, right? Am I right, Uma? And we start from here, I think.
Yeah, I'm not very sure, Gokul. I haven't seen this.
Yeah, sure. It's okay. Vinay, Srivinay, are you here? Hey, correct
Yeah,
me if I'm wrong.
Yeah, sure.
All right. Okay. So we start from here. Uma. So we see T here, and does this match? Does this T match with this T? That's all we are gonna see, right? We have an intersection
Yeah, I think
at this point.
so
It
they're
matches, right?
matching.
Yeah. So we add one here. All right. So what do we do next? So does this C, does it match with the T again? No, right? So it's C and it is T. So it's different. So all the rest of the things are different from T. Am I right? On this column, see the first column, BISECT. All these are different from uh, s- T. So all these columns become zero now. All right. So C, and you have one here. Like whichever matches, you're gonna put one. I mean, initially you would do like that.
There is one more calculation. I think the previous one also you have to add. I
Yeah,
think so.
that is when you have the diagonal. If it is one less than this, Srivanai, can you help here?
Yeah, initially, what you can do, instead
Mhm.
of thinking of, okay, forget the diagonals, forget everything, right? First, just find where your letters are matching and where they're not. So, how would your graph look then? The graph would look where S, so in the row of S, it will be 1, 0, 0, 0, 0, 0, right? Because S, there's only one place where it matches. For now, let's not think of the solution, but for now, let's just think we're going to put a 1 anywhere where two letters are matching, right? So if I do that, I see that at index 3 comma 4, right? Because the fourth letter in bisect and the fifth letter in secret are matching. So there is a 1 over there, right? So how do you understand if there are continuous matching elements, right? So what do you see? You see that the letters are matching. When they're matching, you see that there's a 1. But when you see two letters matching, that means the index 1 above it and the index 1 below it, right? Sorry. How do I, okay, instead of thinking of above and below, let's think about one less of it, right? So if there was a matching letter happening 2 times in a row, it would happen uh, to one index below and one index below in both the letters. Do you understand that? So whenever you see 111 in a diagonal, you need to add them up. You need to see that, okay, when there's a diagonal, it means that there are two letters which are matching in a sequence, and that's why you add up the diagonals in that way. So you can just think of first making a n plus 1 cross n plus 1 matrix, putting the ones where the letters are matching, and then you realize that the common letters, when there's a continuous sequence which is matching, that happens when the one index below, like whenever you see an index below happening, having a 1 again, you add them up. That's what's happening in the entire diagram. So how do you get a 3? That's because the C and the C from the the third letter, and the C from the fifth letter, right? Third letter from secret and the fifth letter from bisect were matching. You had a 1 there. Then you see that the E from the second letter from secret and E from the fourth letter from bisect were matching. So you had a 1 there. So you see that EC was actually matching. So you see that there are two letters matching.
I think we had the table there, right, in the slides without any
Uh,
numbers.
yeah, maybe you make use of that.
We can make use of that, right? Then it will be easier to. Okay, here it is. I mean, that's how we studied. I mean, while we were studying, that's how
Yeah.
we made use of it. Huh. So we can. These are like different cases, right? So for
Page,
director, yeah, you want
page
to say something?
16.
Sorry,
Yeah, we are discussing slide 16.
16. Thank you, Vikram. Yeah. Okay.
So yeah, I plus 1, j plus 1.
Perfect. Yeah.
Correct. So shall we take this empty box and try to fill it?
Yeah, sure.
Here we go. All right. So for all the dots, we need to fill 0, right? Initially.
Yeah.
That's what sir used to tell. Vikram, are you
Then 0
comfortable
looks
with this
like an
actually? With this code already?
Yes.
All right, fine. Yeah, go ahead. Vinay.
Yeah, so you can see that the last letter. So let's start from there. Yeah, that's perfect. So we are going to compare T with S. So this is not part of the algorithm, but what I'm saying is this is something to understand why doing it this way solves the problem, right? Why do you get the longest common word by doing it this way? So the T, when you compare it with an S, it's a 0. It's a 0 because they're not the same letters, and you can
So
see that it's going to be
whenever I
0
see a match, I put 1. That's right.
exactly.
Okay. This
So that's a
doesn't
0
match.
again. Yeah, and there's only 1 there. Yeah. Can you go? Can you write the same thing for that? It's a 0 with S. It's a 0 with E, but with C it's 1. Yeah, with 0 here. Yeah. Before you put that element over there. Yeah, over here after this 1, you can put a 0 for this. Yeah. Now the only way there's a common subsequence, right? You need this. What is a subsequence? Common word, I guess, right? So it can only happen when the previous letter and the next letter have the same have same letters in both the cases. So there's only when there's a 1 on this index, on this grid, on this specific grid, then you know that there are 2 letters which are common in both, right? Because if this C was actually an E, you would see that ET and ET would have been common, right? You would have put a 1 over there because E matches the E at that location, right? So since it's a C, you put a 0. You go ahead. You see that it doesn't really matter. There's only 1 letter till now, yeah. And the T also becomes 0. The next case, that's a 0 because it doesn't match. But here, it matches, right?
Yeah.
So let's put a 1 for now. Let's just continue doing
Let's just
this
continue and finish all these, right? What do you say?
Yeah, exactly. Yeah. There's a 1 over there. There's a 1 in the second last.
Yeah. Ravina or Mahi, like someone else want to fill these 3 guys?
Sir, I have a doubt. Like after the one, we are putting lots of zeros, but what's the need of going traversing through the whole list after one? There's no need of doing that now.
What if there's one letter which is matching in multiple places? So say there was a beetle which is spelled
something like
BEE.
this. No. So even here, see, we have E matching, and if you put all zeros, here also we have one E matching, right? Is that what you're saying, Vinay?
Yeah, a letter can match at different locations because a letter can occur in different positions of the same word, right?
Okay, sir.
Beetle, if you compare it with, let's say, scene, I know you can't do that, but just do it like through this thing, right? No, SEEN.
Oh, scene. Okay.
SEEN, yeah. So beetle. Okay, so you can see that EE is the longest. So you wouldn't have stopped after the first E, right? You would have looked at the second E and realized 2 letters are actually matching, not just 1. Yeah, so with S, again, you have a 1 and then a 0 after.
So I'm going to fill it.
Yeah.
If
I is not common in both, B is not common in both.
Yeah.
Perfect.
Fine.
Now we realize that the only place where there are words matching are places where there are ones. So the letters are matching when there are ones. When there are no letters matching, there are zeros. So whenever there's a 0, it means the same letter is not occurring in both words, right?
Yeah.
So when is the same letter same pairs of letters occurring in the same word? So let's say EC, right? EC is happening at the 4th letter and the 5th letter of bisect, and it's happening in the 2nd letter and the 3rd letter of secret, right? How do you know that's happening? That's happening because at C, at index 5, they're matching. They have a 1, right? Yeah, they have a 1 over there. And even at one index lower for both the letters, you go one index lower, you see that it's still matching, right? So once this happens, you know that there is an EC common between both the words. And you can extend this to any. So this is what dynamic product programming is, right? You understand one case of it happening, and then you just apply it in different stages. So if you see it happening once, you just increment the value by, so just instead of just putting a 1 over there, you see that, okay, there are 2 letters matching. So I'm going to put a 2 over there instead of 1. Yeah. And the same thing I extend it to any other place, right? So I see that the only other diagonal which has 1 in it is S at index 2, 0. So I make it a 3. So this is the logic behind it, but the code, I mean, okay, what I understand from dynamic programming, it's just like recursive functions, right? Not in the in the terms of how it's applied, but in the terms of once you know the base case and once you know the update, it's very straightforward to code it. So don't be too scared about how the code is going to look. Just think about how they solve it, what is the logic behind it, and why is it right. So that's, once you know that, it's going to be pretty easy for you to solve the questions.
Yeah, but one observation I have is like, no, it is easier to understand if you put the same word at both sides.
Yeah,
Okay, same
that's a good
word.
idea. That's a really good idea. Yeah.
Yeah,
You see that the entire diagonal matches. That's
right, right.
perfect.
You will see the diagonal match, and that too, if you take a word which is not repeating, like you take bomber.
Yeah, perfect.
It,
That's a
it is
perfect
all,
example.
yeah,
Around that.
all letters will be different. Then it will be all diagonal.
Yeah. Hi, Anwar. It's been a long time.
Yeah.
So you want me to put that, or shall we move ahead?
Yeah, any 5-letter word which is not repeating, you will see the diagonals are matching, and if you add it up, then it will be
5.
5. It will come, right.
Yeah. So does anyone understand what Anwar just said? Why that is true?
Is that what is it? Does it make sense?
That's
Even if,
also okay.
that's
I mean,
also
yeah,
okay.
even if
You
it's not a
just,
word, that makes
put
sense.
AA1, BB1, CC1. It will be all diagonal.
Yeah.
Yeah. Now add it up.
Yeah.
So it will be 4. 3, 4.
Yeah.
So for the two words ABCD and ABCD, the longest LCW, longest common word is ABCD,
Yeah.
right?
Yes.
Uma,
Yeah, got it. Okay.
yeah.
It's a perfect example.
Let's go to the code and implementation of this. Yeah. So I'll just copy this to the place and see how to run this. So it says like 3. We got 3 as the output. So we have 3 common subword. Length of the common word. Fine. Okay. So who is gonna help me here? Anyone? Uma, can you help? Just help.
Yeah, you want to go through the code? Like,
Yeah.
okay, m comma n is equal to that len of s1, len of s2.
Correct.
M is equal to, yeah.
M equal to 6 and n equal to 6, right?
Okay, yeah.
Yeah. Good.
And we are filling up the LCW with empty dot zeros. Matrix we are,
Yeah. What will this give? This will give us a matrix, right?
yeah, with 0.
So shall we visualize it? Yeah. So we are just creating the zero matrix, just like how we saw in the picture, right? So and this is of length m plus 1 plus n, comma n plus 1, right?
Yeah.
So why we are taking one extra zero here?
To calculate it. I mean, that's how you used to calculate it, no?
No, she's asking m plus 1, why we are taking it. That's what, right?
I'll tell you about that now. I mean, when you see the the formula, inductive formula. Vinay, you want to say answer that?
Yeah, it's just
Starting from zero, no, Gokul. Up to 6 we are calculating. Usually in for loop we don't go up to that number, but here we need that 6.
Yeah. Why is that?
That is what
Her question is, why do we have that?
oh, I didn't understand. Okay.
Why? So was it given in the inductive structure? It should be given, or we can check in the code. I'll answer
You're
that.
asking why do we need that last one, right?
Yeah, exactly. Why do we need that?
For line 11 in the code.
Line 11 in the code. Okay. What are you
So
saying?
that
Upam?
line doesn't throw an error because every ij depends upon I plus 1, j plus 1 according to our code. So the extreme right ones and the bottom row doesn't throw an error. That's why we have this up one extra row and column.
Probably when we look at the code, we'll understand it, right, Vikram?
Thank you, Vikram.
Okay, fine. Shall we go further, guys? Uma?
Yeah.
So max is 0. That's we have initialized. Fine. So we go in the range of what is this?
Column, right?
Yeah.
For C in range, we are going from bottom to up. That's why n minus 1, not top.
So from 5 we'll go till 0.
5. Okay. The reverse order we are going.
5, 4, 3, 2, 1.
Same with the row also. For odd in range, we are going with the reverse way. Again, m out and same thing.
Okay. So just give me a second. Yeah. These many iterations will go. All right. So let's come here. So if S of
S1, first word, the row of the first word is equal to the S2 of C.
so S1 is the first word, right? S1 of R means S1
Yeah.
is the first word and the S2 is the second word, right?
Yeah.
In this case, what is here? S1 of R. R is
No, sir, it's last.
yeah. S1 is the first word. I mean word here. We give two inputs, right, Ravina? Yeah. Obviously, what I are saying is like S1 of R is the first, during the first iteration. It's going to be S1 of 5, 5, right? I mean S1 of 5.
Equal to S2 of 5.
Yeah, that is what we are checking. Again, like coming from the bottom right, as we saw in the picture, right? We are starting from here. I think ideally we are starting from here, starting to fill from here. All right. So LCW equal to 1 plus what is this? So LCW, I mean LCW, we have this dictionary, like we have this, right? The matrix. Hmm?
Yeah.
So R
LCW
comma
5
C.
comma 5, right?
Sorry,
LCW 5 comma 5
equal to 1
1
plus.
plus 6 comma 6.
Ha,
That's what Vikram told.
correct. So 1 plus the previous this point, the diagonal one, right?
Yeah.
So in this case, this will change to 1. Am I right?
Yeah, 1 plus 0 comma 0, right?
That's right. So that
We
is what
need a
is.
diagonal one. Yeah, that's why.
Ha. So that's all. So I think the whole thing is like that's checking. So if the two characters are same, then add 1 to the previous diagonal, right? That is what the thing is.
Yeah.
Okay. So if they are not equal, then LCW of R comma C will become 0. Nothing. If they are not equal, put 0 directly, abruptly. Right?
Yeah.
Okay. And see, we are this is easy. Like we are already calculating the max of W, right? If LCW, the longest common subword. So at this point, let's say you got the point, right? Like at some point we'll have one
Yeah,
here.
I understand.
Yeah, Uma?
I said got it. Yeah, I
Yeah.
understood.
So at this point, if it is greater than max or the previous max, then set it to the max W equal to LCW of the previous one. That's all. That's all. That's all the whole code is. Just like how Steve and I told, right? Only the logic matters here. Anyone can do
No, sir. What that sir told was different. Sir started one line sir started from back and one line sir started from front, but it's starting from backward in both the codes.
I don't understand the question here.
I think she's saying in line number 9,
Mhm.
instead of starting from m-1, she's saying one code started from 0 to m-1.
Okay, I didn't see that.
Which shouldn't be a big difference, right? Imagine you're just going through the word, or what are you doing in each iteration? You're just checking if the letters match. If the letters match, you make it one more than the previous diagram, right? See, when you're in a row 5, the diagonal which you're going to add to is going to be in row 6 only. It's not going to be in row 5, right?
Steve and I, or shall we take it like this? Content deleted. Okay, fine. I can paste it. Not even here. So I'll do a control Z. So what I think she was saying is like it's starting from here, right? Is that what was happening?
I can't see where your pointer is because there are multiple pointers on the
See?
screen. Okay, that one. Okay.
Yeah. So here, if we check out the code, it's like columns and rows, right? For the first, in this case, this is the last column, and Ravina was telling like started from 0, something like
First,
that,
yeah.
right? So this is the row, or let's say like this is the row 0. So what
Can
is
can we have the picture side by side?
you
Can,
want
can we crop that one and put
Make
it
it a
on?
half page, yeah.
the code? You want to have the code also side by
Yeah,
side?
yeah. Either the code or the picture.
Yeah, Anwar, you want to say something?
Yeah, like that. Yeah.
Yeah. So she was telling like if we start from here also, doesn't matter. Steven,
That doesn't matter. So, see, what are you updating on? You're updating on the previous
diagonal.
diagonal. See, the diagonal has already been updated before, right?
Hmm.
It doesn't matter if you start from the first index or the last index because nothing in that row is going to make you change your answer. It's going to come from the previous row and the previous column. The diagonal sits in the previous row and the previous column. So even if you start from index 0 and go to m-1 or start from m-1 and go to 0, it's kind of the same thing. You're just filling it in different directions. So don't worry about that.
Ravina, was it okay for you now?
Yes, sir. Thank you, sir.
Sure. Please don't call me sir. That's fine.
Yeah. Okay. Is this code clear for everyone? Mahi, are you also fine with this? Just 2 iterations. You just do the 2 iterations, and that's all. The only thing is that concept. When you get such scenarios, you just need to think about that. Mahi, you want to say something?
Yeah, sir. In the output, everything is like 0, 0, na?
That's
Can you
because
please run this again?
yeah, sure. That's because see, I put it here. While initializing the LCW, I was putting it.
Yeah,
You want to see at the end how it's gonna look like.
yeah.
Before that. So this should give us.
It should be capital, I think.
No, it's small. We have initialized. Yeah, Mahi.
It's okay. Yeah.
Just like how we got it, we got the answer. So I think is this clear for all guys? Any doubts in this?
Yeah, it's clear.
So shall we go further? And the complexity is m cross n. Why is it m cross n? Because we have 2 loops, right? Ideally, which is of m length and n length. M plus 1 and n plus 1. Okay. So we come to the next problem.
But sir, I have also doubt here.
You have a doubt here or the previous one?
Here's the complexity one. So
Complexity.
whether the length is small or big, we are just creating a square matrix of the greater one length. So
Not the
why it's m
greater
cross
one
n?
length. No, we are not creating the greater one length. Okay. I'm gonna do something. For the bisect secretary, it's going to be different. See? Is this a square matrix? Ravina?
Yeah, it's not. Okay, sir,
Got
clear.
it? Yeah. Fine. So we'll talk about this longest common subsequence. Now, how to find this? So we have the inductive formula here again. So if they are equal, 1 plus, just like the previous formula. If they are not equal, maximum of what is this? Can someone tell? Guys, whoever has watched the lectures. Maximum of the right one or the below one? I think that's what is happening here. Let's see. I'll take the picture. For the same thing, we'll do the. I mean, it's bisect and secret. We'll take the same. Yeah. So how to find the longest common subsequence? So does everyone know what is subsequence, guys?
Yeah, yeah.
Mahi, Ravina, Vikram. I think Vikram knows it. Okay. So how do we find this? So just like how we did the. Okay, I'll just copy the inductive structure. We had. Here we go. Hey, can you guys talk about this? I'll come back in a minute. I just need to take my charger.
Uma, I have a doubt here. Can you please help me?
Yeah, sure. Go ahead.
Like, why we are finding the longest common subsequence? Because in the previous code, we find it the common subsequence. So we can find all the common sequence and we can find the largest length of it. So why we are writing a new code for it?
Okay, so I'll define subsequence and I'll define common. So, what is a subsequence? They're talking about.
Go ahead. Go ahead.
Yeah. Are you back?
Yeah, I'm back. Talk.
Okay. So, when we talked about longest common word or the length of the word, which is the longest, we only took in account the ones that were occurring in a sequence, right? You were only looking at continuous letters that were matching, right? But in terms of longest common, I'm not really sure about the terminology. Is it I think it's longest common subsequence, is it?
Yeah, subsequence.
Subsequence. Yeah. In that sense, they're just looking at. So if I take different, so not non-connected letters, and I patch them up, right? What is the longest? What is the commonality in both, right? If there's a letter, if there's a word, and there is and I want to match with it, it doesn't have to be continuous in the first word. I just want to take bits and pieces of it, put it together.
Sir, I got it, sir. Thank you,
Yeah.
sir. I
Okay.
got it.
Okay. I think Google's diagram is much better to visualize it. Visualizing is much easier. Yeah.
Mhm. So how do you find this? So that's why we have this inductive structure. So this is all that we need to know. All right. So as usual, we just put 0 for all these things. Right. So Uma, would you like to help me to fill this, or someone else? Ravina, would you like to fill? Ravina.
No, Uma.
This Ravina, you try just filling. No? You can try.
Tell her, Uma. Tell her to fill it.
Mommy, stop it now. One at 5,5
Why?
because it's same.
Yeah, that's right. Because it's same, we are gonna put 1. Okay. Then we'll go here. So this is going to be
0. 0.
y 0.
But here,
Look at
no,
that.
sir, we will not go here. Sir, we will not go here.
Okay, tell me where to go. You can go anywhere. Tell me.
We will go, yeah, there.
You want me to go on
0,
the left? Okay, fine.
0.
It is 0. Earlier it was 0. See, now we are trying to find out the longest common subsequence. Okay, when now we have t and e. When t and e are not equal, they are not equal, right? So we need to find I plus 1 comma j. So I is going to be at this place. What is I? Let's say
4.
let's say 5 comma
No,
4.
5, 5. 5, 4.
I'm not sure if it is 5 comma 4 or 4 comma 5.
5, 4.
This is what we call as rows and this is what we call as columns, right?
No, sir.
Okay.
That 0, 1, 2, 3, 4 verticals
okay,
are
fine.
rows
Okay.
and horizontals are columns.
Okay. And if that is the case, so we have 5 comma 4, right? So I is 5, j is 4. Okay. So what is I plus 1? It is 6 comma 4. What is the value of 6 comma 4? Ravina?
E, what is
0.
Hmm.
Right. Okay.
Yes,
And
sir.
we also have 5 comma 5. So what is the value of 5 comma 5? It is 1. And we are supposed to take 6 comma 4 is 0 and LCS of this is going to be 1. What is the maximum of 0 and 1? You need to put 1. Okay.
Mhm.
So basically the point here is if the 2 points are matching, just add 1 to the diagonal and put it. All right. If they are not matching, put the maximum of the left bottom or the right. Got the point?
But where to put, sir? Where to put?
Put
I'm
it on
not
this point.
clear.
So now we are talking about this point. Okay. So look at the bottom. It is no, first look at T and R. Are they matching? No. If they are not matching, look at the bottom elements and the right element. So we have 0 here and 1 here. What is the maximum of these two?
1.
Very good. Okay. So similarly, so T and C doesn't match. So put the maximum of these two. 1.
1, 1, 1.
Very good. 1, 1. Okay. Now we come to this line. Okay. C and T doesn't matter. Put the maximum of these two. 1. Go ahead. Ravina.
All 1. Nee, at 2 it will be 2.
Correct. So when it is
No.
equal, add 1 to the diagonal and put it here. Right. So next.
2,
Maximum.
2, 2.
Very good. 2 and 2. Nice. So here, maximum of these two. 1. Maximum of these two. Again. But this is an equal, right?
1,
E and E are equal.
2,
Good.
2,
2. So maximum of these two are
2,
2.
2, 4.
No. 2 plus 1. See, when they are equal, whatever the bottom diagonal one, right? Diagonal 1 plus 1. Got it?
Plus 1, 3.
Very good.
3.
Now maximum of these, right? So here also again 1. May I fill this up? Hope you understood, right?
Yes.
Good. I think nothing else much is there. So here it is going to be 3. And in this case, it will become 4. Am I right? Hope I'm going right. Correct me if I'm wrong. 2, 2, 2. For this, it will become 3. And I is not matching, obviously. So it's 4. So in this case, 1, 2, 2. B is also not matching, right? So I can directly put it 3 and 4. So let's just check it. Yeah. See, 4 3 triple 2 1 0 4 3 triple 2 1 0. That's nice. Okay. Luckily, I am saved.
Sir, it's not clear.
Which is not your right hand side or right left hand side?
Sir, I have a doubt. After that 3, 1 comma 1.
Okay.
No. 1 comma 2. After that, how it became 3.
Which is 1 comma 2? This point? Sorry, this point.
Yes, sir. Then now
Maximum
it
of these
can
two. The bottom and the
shoot
right, maximum is 3.
bottom.
Got it?
Yes. Mm.
Ravina?
It's clear, sir.
Great. Okay. So that's all this is about. Mahi, are you okay with this?
Yes, sir.
Great.
Uh,
Nice. So any doubts there at this point? Like how to calculate this? How did we put this? Is everyone clear with this?
Yeah,
Alright.
got it.
Yeah. So now we'll go to the implementation part and see. Just like how we used to do, right? What's the previous code? Did everyone understand this? Or do you have any doubts in this?
No, we got it.
Okay. Yeah. So let's run this. And again, can you help me, Uma? Or Mahi, would you like to help me here? Same code, nothing else is here. We just have an if and else.
No, sir, Uma.
You are not going to answer, but you are telling everyone else to answer. Huh?
Sir, Uma explains very good, sir. I only understand Uma's code.
God.
Uma, you have a fan follower. Can't do anything.
Okay, so initially we are same thing, I think. M
That's
is
the
equal
same
to,
thing.
yeah, and LCS we are initializing the matrix, and
Correct.
for C in range, we are going from reverse, n minus 1 to minus 1, and same with the rows also.
Yeah.
So it's the same thing. S1 of R equal to S2 of C.
Mhm.
In the longest common sequence, RC equal to 1 plus LCS R plus 1 C plus 1, right?
Correct.
If it is same.
Yeah. If it's
Else,
the
we
same.
go
Else.
for a max of LCS R plus 1 C,
Mhm.
comma LCS R, comma C plus 1. Either the previous row or the next row.
So shall we just compare the previous code and this? Then it will give us a nice idea, right? I mean, mostly it's same.
Yeah, except the else part, I think.
There is little bit difference, nothing else.
There's one more difference. Find out.
How do I zoom this out?
Yeah, we're returning the max where we are taking the 0, comma 0, right?
Yeah, because we don't have to store the variable anymore, because we know that the 0, 0 will be the maximum.
Yeah.
Yeah, that's good.
Yeah, okay. Is this okay with everyone? Anwar, you have any doubt? You want to ask something? Guys? Okay.
No, it's okay.
Yeah, fine. So Mahi, are you okay with this also? There is nothing different in this code. Just easy. 2 for loops and you have the if and else condition and return the LCS of the lowest.
How to recreate the subsequence.
Yeah.
One doubt to Vinay, Sri.
Yeah.
Yeah, sure.
Yeah, how do we say these all comes on a dynamic programming? Because it looks like it is a normal coding. We start from the variable, and because it doesn't look like sub problems. Are we having sub problems and then going from base case to that?
Okay, so there's one algorithm that you've learned before that uses
Because the
that.
grid parts I can understand it's, but here it is looks like a normal program. Now, how do we say this is dynamic programming?
Yeah, so to think of it very in the base sense, you can think that something that you've used, some result that you've obtained before, you're making use of the result to
Oh,
obtain the result for the current thing you're calculating, right? So you
okay,
use the result of the fifth row in the fifth column, that diagonal,
okay,
to get the value of the next diagonal, right? The fourth
okay.
index
So
in the
that
fourth.
is fine.
Yeah.
Okay, thanks.
Can you give me one more example of a dynamic programming algorithm that you've learned before? You've learned it in week, let's say 6 or 7, I guess. Is it 7? Okay, go to week 8. Week 6. Yeah, in week 6, actually, week 6. You've learned one dynamic programming question. You've learned an algorithm that uses the results of the previous.
Crystal, is it?
Yeah, exactly.
Yeah,
So
we calculate the component, right?
exactly. So
Right.
Driscoll's algorithm is actually a dynamic programming question. So it
Okay.
uses the
Previous result. Okay.
yeah.
Fine.
So that is a small confusion. So dynamic programming, we say solving subproblem, and then only memorization, we say we calculate and keep it in memory. But now you're telling even the critical comes under dynamic, right? So even dynamic also applies at storing the results and then applying. Is
No,
that
but you can reduce the storage. So we don't need to store. What we need is only the previous one and the current one. Like the
okay?
you only need two things. So you remember you can reduce the space complexity by storing only two, right?
Okay. Okay.
Yeah.
You don't
So
have
in that sense,
to.
you're not actually storing that information. You are just making use of the previous one to get the result for the current one.
Aren't we
Okay.
storing this here?
No, we are not
You
storing.
just see. You're not storing it. What you're doing is you're using the previous result just one level before. You're using that information for the next level. That's all.
But anyhow, we are
Think of it.
putting it
Think
inside
of
of
this.
the matrix, right?
Okay. That matrix. But what? So think of it in this way. Um, I have five letters, right? Once I know the value for the fifth row and the fifth column, right, completely, I don't need anything else before it to actually get the fourth row and the fourth column. I don't need anything else before the fifth column for the third. Sorry, if I'm calculating the third column and the third row now, I don't need the fifth column. I need fifth column in the fifth row. I just need the fourth column in the fourth row, right? So in that sense, you're just using the values that you've just computed for the next iteration.
Gokul, we can say like this: we are not especially having any story memory space for storing, right? We are just anyway we are going to calculate the matrix, but we are utilizing the previous value.
Exactly. That's perfect. I think that's well better explained than me. That's perfect.
Okay. So we also have a little bit of time. So shall we also discuss about this edit distance, guys? Here.
Yeah, we could finish this week. Yeah.
Yep. Hmm.
So one study session and all of you finish one entire week. Isn't that unfair?
No, we are not finishing the entire week
Nice.
now. We still have
No,
one
I'm
day.
just kidding. I'm just kidding. It's nice to see that
Am
all
I
of you are
audible?
discussing so well. Yeah.
Yeah, you're audible. Go ahead.
Hi, Nikhil.
Sir also told about how to recreate the subsequence. Means here we are only calculating the number of letters that are matching. But what now? What are the letters? Sir told to do it ourselves.
Yeah.
Recreate
So
the
do you want me? Do you want us to discuss a problem? So you think you want to discuss that problem?
Yes.
Yes.
Okay, that'd be great, right? It's a good idea.
Yes.
So you want to discuss how to return the
Ah,
greatest subsequence. You don't want
yes.
to just return the length of it, but you want to return the.
Sequence. Yeah.
It's a
So
good
this one,
idea.
right? Subsequence or the word? Which one?
Let's do word. Word is
Any,
easier. Subsequence.
any
I mean,
Which one is harder? We'll do that.
subsequence will be harder.
yeah, subsequence will be harder because it's not continuous, right?
Yeah.
Yeah.
So do easy ones, sir.
Okay.
No, yeah. You see, once you understand the
Beginner's
logic,
time.
I'm
Huh.
telling you,
Yeah,
in
yeah.
PDSA,
Let's
understand
go
the
with
logic, and then you just have to extend
yeah.
it to
We'll
other
get an
problems.
idea first, Gokul. Let's go for word, then we can go for subsequence.
Yeah.
Sure. Let's print that whatever we have calculated. LCW. Anyhow, we need to go ahead with it only, right? Whatever we have. All right. So how do we move ahead here?
I think we need to pick up the largest number first,
Okay.
then move
You want to
That
move back.
diagonally, right?
Mm-hmm.
move that.
Yeah, if we print 3, 2, 1, we will get the sequence. I think so, right?
Mm-hmm.
I'm not sure.
But how do you know that 3 is sitting over there? How do you know
Yeah. Now,
that it's
some
sitting over there? You
max.
need the
Go
index,
some
right?
max, right?
Yeah, max is actually just
Yeah,
a value, but it's
yeah,
not
yeah.
storing
It
the
won't.
index.
Yeah.
Yeah.
True.
Yes,
So we
ma'am.
can make a string, sir. We can make a string, and where there is an equality in line 9th, we can add those letters and we will get that word.
awesome. That's a great area because you are actually finding out the letters that are matching while implementing the LCW. You are not finishing the LCW and then trying to find the letter, right? So you're doing it on the way. But okay, let's think about this. Okay, how would you implement this? Anyone wants to think about? So, did you understand what Ravina is trying to say?
Yeah, Afnan, please come in.
Yeah, sorry. So am I audible?
Yeah.
Hi, Afnan. Nice to meet you.
Yeah, hi. Hi, Srinivai. Good to see you here also.
Yeah.
So no, I was just saying that when we start from the beginning, I mean, beginning in the sense that we start from the topmost column and the leftmost row, so as to say that top left diagonal element or whatever that is. So if you go that way, then we'll have to change the inductive structure also to say that it is 1 plus LCW of R minus 1 C minus 1, I believe. Is that correct? Because we are starting from the top left and we're going downwards. So in that way, if we calculate, then the previous one will actually not be the R plus 1 and C plus 1, rather it will be R minus 1 and C minus 1 is what I believe. Is that correct?
Are you suggesting that change? Because I think we are starting from the bottom rightmost element in
No,
this
so
sense.
not suggesting a change, just was asking that if we do so, if we start from the first one, then we'll have to change the inductive structure. So if you
Yeah,
do that change, then will it be correct or like?
there are two changes that you need to make. So, so in this, you see, programming this is easier because okay. So you started with the last column and the last two are zeros, right? What you have
Exactly.
to do in your implementation of this, where you start from the top left corner, is that the first row and the first column should be zeros, just like how you made it for the last row and the last column in the others, right?
Because R minus 1 and C minus 1 should not give us an out of
Exactly,
bounds. Yeah.
exactly, out of
Ex-
bounds. Yeah,
yeah. Okay. Understood. So then it will be like
and it's
we are
the
just,
same. Yeah, it's the
yeah,
same.
everything is same. Okay. That was my question. Thank you.
Perfect. Okay. So, Ravina, do you want to rephrase or retell your implementation? How do you think we can find the longest
No,
subcode?
no, sir, nothing, sir. You can continue, carry on, sir. I'm weak at coding, sir.
No, okay. So I'll be honest. I'm not good at coding either. I'm only good at understanding the logic. And once you understand the logic, trust me, coding is nothing. I have never learned coding till now, till I started this course, and I'm not pretty good at it. I just know the logic, and once you know the logic, that's all you need. And your logic was perfect. I think you were able to find out that you can actually find the sentence as soon as you see that the two letters are matching. So can you tell us how to go ahead with that? Okay. Anyone else?
So, like she said, can we try at that point when we find it equal, add it to a new list kind of thing?
Okay, so first you need a string to store the variable. So let's call something. Say you can't name it string, buddy. You can't name it that, yeah. Yeah. So you're starting with an empty string. And she said every time you see a letter that is equal, store
Yeah,
it.
yeah, either S1 of R or S2 of C, right? Kind of like that.
Mhm.
What should we do? Store where? The string.
Yeah, store the string. So you add that letter to the string. So string is equal to string dot append, right? I don't know. I
So we can do
really
this
not sure.
also. No?
So okay, one suggestion here. So if you do it this way, we're adding to the string in the forward sense, right? So we are starting from the back and we just keep on appending to the right of the word that we have. Then we'll get a reverse of what we need to get,
Yeah.
right?
Yeah, finally,
So
we can do
in
this,
that
right?
case, there are two options. Either we can start from the top left, as I suggested before, or otherwise you can do this, right? I mean, you can do
Insert it. Yeah, insert
uh,
it in the front, right?
at the yes, exactly, at the end. Or there is this other way of doing. What we do is we do.
And then reverse it.
No, we don't do a string is equal to a string plus s1 of r. Rather, we do a string is equal to uh, s1 of r plus string.
Yeah, that will
That
revert
that
it.
is the way to kind of add it to the reverse
Automatically
one.
reverse. Yeah.
Yeah.
Perfect. That's right. Okay. Now you manipulated the string, but are you sure you should change it every time you see some two letters that are matching? So do you think, yeah. So what we want that variable string to store actually?
Yeah, we can't do because it should be consecutive, no? So
Yeah.
it should be something to do with the diagonal elements because we change diagonal only when it is matching consecutive, you know. We should find a way to match it.
Actually, if we in the last iteration, if we in max W, we are getting the R and C. Can we use that R and C to calculate LCW of R and C, final R and C value?
That is definitely one way to do it. If you think you want to start out with that, you can do that. But don't you think while doing the loops, you can...
But while doing the loops, we are also going to get the shorter strings also, no? Like the one.
But you're checking someplace. At some place, you're checking. Yeah, where Gokul is at right now, you're checking whether the max word has changed or not, right? So why can't you make use of this part of the
But then if equal to and we are adding string, then we will be adding P plus T also.
Yeah, that part is wrong. You're right. You can't do it at line number 11 because you are going to change the string every time. You're going to add a letter even when they're not matching it at a continuous sequence. So I suggest remove that line. And I suggest why don't you do it only when the max is changing?
Yeah.
Perfect.
That's right. Okay.
Paste it if you can. Yeah. Does anyone? Okay. So do you think this solves the problem? Do you think this will always give us the right answer?
No, sir. No.
Perfect. Yeah. So you understand that there can be an issue where where you're
Max,
actually appending two
path to
letters from
max
a
may
different.
be different.
Yeah. Exactly.
So the earlier thing we were trying, string equals to S1R plus string.
Yeah.
So if we can check if SR minus 1 is equal to S2 C minus 1, only then we add the string.
Repeat. If we check what? R minus 1. That means the previous upper diagonal.
The string statement that you have written,
Yeah.
you can just put it below this LCW.
Fine. Go ahead.
And we can put the string statement inside the if statement.
Sure.
And there we can write if S1 R minus 1 equals to S2 C minus 1. This might work, I think.
So what are you checking here? Can you
What are we
explain it
doing?
to the others as well so that they understand?
So we are just checking if the earlier letter also matches.
No.
We
Okay.
don't match for all, right?
Only then we add the string if this statement is true.
Okay. Does anyone see that there's going to be an issue later? Or do you think this is the right answer?
I can't think we can build up the string while looping.
Can you print and check, please?
Sure.
Sure. At the end, right? Basically.
I think in this case, you will actually get the right answer, if I'm not wrong. No, you will not get the right answer. You will get an extra T. You will actually... okay, I'm not sure why it's just
one we
easy.
don't get, yeah.
The thing is, actually, what happens is, at this point, okay, it's not able to find out. We don't have anything, right? Something like that. When you go here.
Can we just start with the C in MacWC and take a subsection of the string? The C is looking over which string, S1 or S2? C variable.
So probably, I think that I'm just guessing this. Okay. Max plus string, max W. Oh, okay, sorry. What was it? Max W. I mean, I'm just saying like whatever we are having here, right? So probably we'll have the maximum value at some point, right?
Yeah.
Mm-hmm. So can we
The
take
C,
that?
what will be the value of C here? Max W, LCW, R, comma C. C will be 0, na?
Yeah, it'll be 0.
So S1 of 0, comma max W minus 1. Slice of the thing.
That gives you S. Yeah, exactly.
That will give you our answer, na? C will be the starting index and max W minus 1 will be the
Max
ending index.
W is
This
We
3,
are
the length of the letter,
length
not
of the
correct.
yeah,
That's the length of it.
yeah. So if you take the slice of the S1 starting with C and ending at max W minus 1.
starting from C, ending.
C ending at max W minus 1. Slice of string S1.
Mm-hmm, that's right. So okay, perfect. So what he's saying is the string 1 is actually storing secret, right? I think bisect.
Yeah,
Bisect.
Okay,
It's
sorry,
bisect here.
bisect.
bisect. So he's saying, why don't we just return
Mm-hmm.
the index of C, columns, the
Yeah.
value C. So you're saying we just stored this indexes at that time, right?
Yes.
So that we need to. So that means we need to store it there, right? That's what I was
Yeah.
asking.
So why don't we just say max R, max of R and max
Exactly.
of C maybe? You don't need R, is it? I don't think we need R, right?
I R
You
or
don't
R
need
S, anything is fine.
anything declared.
Everything is fine. We'll initialize with the -1. Mm-hmm.
And then at that point, he says we can just update to that R. Yeah.
R or C, I am
Just R.
confused.
Yeah, take
C is better. I think I was able to visualize C. I'm not able to visualize R yet.
Anything is fine.
Yes. C.
Fine. So now we
Max
got
C
this.
is 919, max C is equal to.
Sorry. Go ahead.
So in the end, he wants to print S1, index it from C.
Okay. So he's not making use of this. Fine.
Yeah.
S1
Of C.
Index
mm-hmm.
C
C
colon max W
Max
minus
of
1.
W
Minus 1.
Yeah.
Okay. Let's see this. Huh?
No, C, no, max C. Max C.
Oh, max C, sorry. Yeah.
Max C.
No, max C to
Okay.
max W minus 1. Max C to max
Why is the
W
error
minus
in this line? I'm getting an error in that line.
Max W minus 1.
You're getting an error in that line? Try it again.
Indices must be 0. Saying that indices. Sure. Okay. Doesn't see index. Slice indices must be integers or none.
SW. S2 शायद. Yeah.
No, the error is.
Oh, it's just saying it's either receiving a 0 or minus 1, is it?
The error seems to say that the index that we're providing is not an integer.
Exactly.
Yeah, can
What
you
it
print
is?
max C and max W? Yeah.
That's what I'm trying to do.
3.0. Okay.
No, again.
Oh, that is
It's coming.
max W is double.
Yeah, double. It's not a.
Yeah, we'll make it as int now.
Yeah.
Oh, I don't. Yeah, the minus 1 is not required. That's what I was thinking. I don't know why. This is a nice way to do it. Yeah.
Yeah,
Okay.
let's try something else also, right? See if it is working for other things also. Okay, now see, it should be secret. Works.
Yes.
That's great.
But would this work if you put S2? Can you write top secret and see if it works?
So you're saying we need the.
No.
Okay, we need
Because
the
it has to be in the
rows.
beginning.
Mm-hmm.
If the subword starts from the beginning, only then it will work.
Okay.
Hmm. So in this case, see, we have this, and we have the matrix like this.
So probably if we get the maximum, the index of the
Row
maximum value in
also.
the matrix, yeah, then probably we
Oh,
can
I
do.
can't see. I'm just thinking of something. So at the end, yeah, just like how Afnan told, right? So at the end, we'll store the maxi, right? Just like how we do that. So we have maxi, and obviously
We
we'll.
store the index itself instead of just the maxi. Why don't you do
Hmm.
um
So why can't we? I'm just thinking like, why can't we add it up here? Like this is how it will go, right?
mhm.
So it's gonna be CSECRET. Thought like, why can't we take the diagonal?
So
We
That's
have
what
to
I
check
told first. Yeah.
all diagonals then.
I'm sorry.
We'll have to check all the diagonals then.
No, only the from max below.
From max and the below.
Yeah, I told that first, but I don't know how to code. That
So
was
if we have
something
six,
I told.
let's say like we have six here, right? So that means starting at this point, okay. So next six are gonna be the same. I mean,
Or
or the
So I
subsequent.
you
minus
can
one, I minus
you
two.
can do hello,
Yeah,
hello.
yeah.
Maxi in the slicing int max w plus maxi
In
plus maxi.
okay. So you want me to change this,
No,
right?
no, max is there
Fine.
and int max w plus max.
How this max?
Mm.
Okay.
Yeah, this will work.
Are you sure?
Yeah,
Yeah,
check it.
because you're starting from 3
Yeah.
and you want the next 6 elements, right? So int of max w is actually giving you
Maximum
6.
length.
But you
Yeah,
are
yeah.
trying to shift the elements by 3. Okay.
Exactly. That's right. Now this makes sense. Yeah.
but this will not work for the earlier strings now.
Yeah, it will work
What
because
do you
max
mean?
will be 0 in that
Mm,
case.
yeah, wait.
Oh yes, correct.
Yeah.
That was good.
Like, S2 as secret. Still work.
Yep. This. I think this is one of PPA or GRPA, right?
I don't know.
I
Not
don't know.
really
Like,
sure.
probably there was one question like that. As far as I remember, I don't know. Fine.
Actually, I joined. I have not watched the lectures.
Okay. So any doubts here, guys? Before we close up.
Yeah, I don't get it. Can you understand briefly, Gokul?
Okay. Repeat. What did you say?
Can you just tell again that I didn't get the
Yeah.
Nikhil?
What and all we had changed, right?
Yeah,
Okay.
briefly.
I don't need this. It's also not required.
But this will work in only max word case. It will not work in subsequent case.
That's right.
Yeah, you might have to think of a different way
Yeah.
of that.
Yeah, you can again still come up with this like similar way, right? And try to find out how to do that. Fine. Uma, coming back here. All right. So
Yeah.
only change we did is like we are okay. So at this point, at the last thing, we'll find out the which column it's gonna get stored. Right. In this case, see at this point,
Okay.
okay, whichever
Okay.
column it belongs to, like 0, 1, 2, 3. I'm not sure,
The
but let's.
maximum value, right?
So this is storing in the fourth column.
Okay.
Let's say like that. All
No,
right.
no, the 0 column, 0.
Zeroth column, but fourth row, right? Okay, yeah. So zeroth column. Okay, fine.
Yeah, you're only storing the column. Yeah.
Yeah. So zeroth column. So this is getting stored in the zeroth column. So that means,
Okay.
and we know the maximum length, word length,
Yeah.
which is 6.
Yeah.
Okay. So, and what are we doing? We're just taking maximum, whichever column it's starting from, right? So here it is 6. So starting from here until 6 points, like max C. This is the length of the word. I mean, common words, right?
I'm not getting that point. Maxi colon. What does that mean?
This is okay. This is string slicing. Have you heard of string slicing?
Yeah. Oh, okay. Yeah. Got it. I didn't get it.
That's
Yeah.
all. So starting,
Maxi.
yeah. What is
Okay.
max C for us here in this case? It is
0.
very good. So 0. Okay. So I'll put S2
So that's
off.
Latin from 0 to
0 to, what is the length of that? It is 6.
max W, right?
Hey, my father is
6.
keep on calling. Give me. அப்பா அர்ஜென்ட்டுங்களா நான் கூப்பிட்றேங்கப்பா 10 நிமிஷத்துல.
Yeah. So it's just so you're just trying to find the index of where it's starting, and
Okay.
you're getting the next 6 elements, right? So where did we find an issue over here when it was not starting from 0? The index was starting from 3. Let's say, right? Let's say just RET was the common word, right? In S2, you
Okay.
see the word is SCC RET. If
Yeah.
you see that RET is the only common subword,
Yeah.
you have to take from 3 to the max of the word is 3. So if you just put it to max of C to max of W, you will see that it's 3 to 3, right? 3 to 3 doesn't make sense. You can't, slicing it doesn't make sense. So you have to add the index back of how many elements you skipped before. So if you skipped at 3 elements, you're just adding 3 more elements in the last to get all the 3 to 6, right? 3 to 6 is your indexing there. Yeah.
Yeah. Thanks.
0, nothing else. Works? Is it fine? Ma?
Yeah. Got it.
That's all. Ideally, we will have one question. Let's see. Let's show it. This is the max value. Max
No,
plus.
not the PPS.
Yeah, PPAs, I'll be discussing on Thursday live session, I guess.
Okay.
No, this is done, I think. This PPA is done.
Yeah, the next one.
Yeah,
The
and
week
then
10.
next week.
Okay. Longest. Fine. Okay. Shall we call it a day now, guys? I need to go now.
Kukul, you have DSA this term?
No, bro. I completed it.
Yeah, you completed it. Right? Okay.
Yes. Fine. Okay, guys. Anyone else want to say something, or tomorrow we'll join?
How often do you guys join? I'll maybe try to join once in a while.
We'll send you the link. Srivan, we have a WhatsApp group.
Okay, great.
Right.
If you can
So
add me there, it'll be nice.
Yeah.
Sure, guys. Okay, thanks, guys. Bye.
Thank you.
Bye.
Gokul, tomorrow what time? Same evening, 7 o'clock.
Same
No?
to same. Same time. Yeah.
Right.
Yeah.
Thank you. Thank you very
Yeah.
much.
Thank you. Bye bye. Tomorrow we'll finish these up. Bye bye.
Yeah. Thank you.
Thank you, guys.
Bye. Afternoon. Thanks for joining. Mahi,
Okay, bye.
Ravina, bye bye. Shikram, bye.
Yeah, nice session. Bye.
Yeah, sure.
Thank you. Bye.
Bye bye.
So Vikram, are you there?
Yeah, he's still here.
Yes, Afna.
Yeah.